Okay, so like I said, I'm going to do a little bit with the vocab here for you guys. Now, both sine and cosine, all this vocab stuff, it's the same. I'm just going to use the cosine as my example that I'm going to use to help explain this stuff. But it works for both. All right, so the cosine, when we were over here at negative 2 pi, that was at a hill. And then it was back up here, so halfway is down. Okay. So negative pi, it was down here. So it looked something kind of like this. And then this was at 2 pi over here. This is pi. This was up at 1, and then this was at negative 1. All right, so there's our cosine. So there's some different features of the cosine, some different measurements, if you will, we can take of the cosine, and they have different names. And some of this stuff, if you guys have done some work with waves in science, I don't know if you have at this point, you might be familiar with some of this stuff. Okay, so the first thing we're going to talk about is period. Okay, if something is periodic, what does it mean? I know what you're all thinking. Get it out of your head. It does actually work. That definition of that does work the same way. But get that out of your head. Something that happens periodically, happens every so often, right? Okay, so something that is periodic happens every so often. So this function repeats itself, right? Keeps going and keeps repeating, keeps repeating. A period is the how far it takes before it repeats. Okay? So the period of a cosine, if you look at the x-axis, how far before it repeats itself again? 2 pi, right? Okay. So the easiest way to measure that is either from max to max or min to min. Okay? Or I think in science they say like hill to hill and trough to trough or something like that. There you go. Crest to crest and trough to trough. Anywho. So this distance is called the period. Yeah. For emphasis. For emphasis. Okay, now, we're going to be looking at some different waves later on. So the period could change. But a regular, normal, nothing funny going on cosine, the period is 2 pi. Okay? All right. Another measurement we can take, and yes, I'm going to use another color, is not measuring this way, but measuring this way. And it's not all the way from the bottom to all the way to the top. It's just from here to the max. Yeah, say that again. Amplitude. So that distance right there, from the middle to the top, or technically you could say from the middle to the bottom too. It's the same distance. That's amplitude. So for this particular cosine wave, again, nothing funny going on. What's the amplitude? 1. Okay? Normally, the amplitude is 1, like in this one. Okay? Then the only other two things that you might have that you'll need to know about and vertical shift. And vertical shift you've actually already seen before. Okay? A vertical shift is how a function has been moved up or down, right? And phase shift is going to be like your horizontal shift. How far to the left or to the right has it moved? Okay? So it's hard for me to show you those exactly on this one because this particular wave that you're looking at has no vertical shift and has no horizontal shift or phase shift. Okay? So we're just going to write those down underneath and define them so that way if we start looking at some later on, we can start to identify that stuff too. So vertical shift. Basically just how far up or down has it moved, because sometimes we're going to see these sine waves that are graphed where they won't be x-axis anymore. Might take that whole wave and move it up. Okay, so it has a vertical shift to it then. Shift. AKA horizontal shift. That's fine. Well, I'm going to use the word phase, just so you know. But so that is going to be how far left or right. Okay, so if I have an equation of a cosine or a sine, where do I see all this stuff then? Okay. Well, every sine and cosine, and again, I'm just going to use a cosine as an example, but it works the same way with a sine. All of them can be written as a function like this. All right, now I'm going to just tell you what they are. We're not going to have time to really delve into why right now. Tomorrow we will, okay? But I just want you to write this stuff down for right now. So A, whatever this number is right here, that's the amplitude. Two pi divided by B, again, I'll explain why tomorrow, but 2 pi divided by whatever this number is right here, that's the period. C is the phase shift. And D is the vertical shift. So what we're going to do is I'm going to give you some equations of some cosine and sine waves, and we're going to see if we can pick off this information and then use that to draw a graph of what it should look like. All right, stay tuned. I know. Yeah, he's fine. Okay, here we go. Shh, guys, please stop. All right, so just a quick review of what we talked about yesterday. Okay, so we looked at the graph of cosine just as an example, but any cosine or sine wave has the same stuff going on. So the period was how far in the x direction it took before things started repeating. The amplitude was essentially how tall the wave was. Kind of if you had drew in that midline, like the x-axis is our middle line here. So how high off of that or how low below that it gets. And then we talked about vertical shift, which is taking the entire function just like any other function you guys have looked at and moving it up and down, and how far is that. And then the phase shift, which we also know as the horizontal shift, and that's how far left or right it went. Okay? And so we had every trig equation looks something like this, or that cosine might be replaced with sine, but it works the same way. And you got this A, B, C, and D that are going to be in there, and we need to use those to help us figure out amplitude, period, phase shift, vertical shift, or I give you those 4 things, and then you have to use that to come up with what the equation should be for that. Okay? So, said yesterday that we would kind of explain this a little bit more today. Okay, what these are and why they are where they are. Okay? Think about transformations of functions you've done in the past. Okay? The phase shift and the vertical shift stuff should make sense already, right? How far up or down, how far left or right. Okay? And when you did that in an equation, anytime you added or subtracted something with just x, that was the left and right movement, right? Correct? And anytime you added something onto the end of it, that's what made it go up and down, correct? Yeah. Okay? Now, we've got this A and this B. Those are transformations that you've done before too. What's the A? If you multiply in front of a function by something, what does that do to the graph? It's a vertical stretch, right? Look at the amplitude. Isn't that just a vertical stretch? It's telling you how tall the wave is, right? That's a stretch. That's a vertical stretch. Okay? The B on the inside, that changes the period. The period tells you how wide or how short it's stretched horizontally, right? Which is then a horizontal stretch or shrink, depending. Okay? So it's really those same four things that you've looked at before, just kind of, we call them different things when we're talking with trig. Okay? And the only thing that's really different beyond that is the period thing. Okay? So the period is not a measure of how much it stretched, like what factor did it stretch by. A period is like physically how far is it before it repeats. So there's this little like conversion equation that we have. Whatever this b is, that's how much we've stretched it. But then to figure out, okay, then if that's how far we stretched it, or by how much, to get the actual new period of the thing, it's 2 pi divided by that number then. Okay, so we got to run it through that little equation to actually figure out how far apart it is now. Okay, and the reason we use 2 pi is because if I didn't do any kind of stretch whatsoever to a cosine, like this one right here, okay, this is like your basic nothing has happened to it yet cosine. What's the period right now? 2 pi. Okay, so if I were to stretch it by a factor of 2, so it's twice as stretchy this way, what's the new period have to be? 4 pi. Okay? Or if I were to condense it so that it is twice as condensed, what would be the new period? Pi. Okay? So think about that last example that I just gave you. If it was twice as condensed, what would be b? Twice as... b would be 2, actually. Remember, it's always the opposite. You guys remember that from doing transformations? The horizontal stretch and shrink. If the number is actually bigger than 1, it's a shrink. If the number is less than 1, it actually makes a stretch. It's always that opposite. So if b is 2, it's actually a shrink down. Okay? So if the period is pi, that means b must have been 2. So 2 pi divided by 2 gives you pi. If it got stretched out, so it's twice as stretchy, you guys said that that would be 4 pi, right? If the new period is 4 pi, what did I actually divide by? 1/2. Okay, see how it's doing that opposite thing? Okay, so 2 pi over b gets it done every time, though. Tells you what the new period is. If you just remember that, you'll be fine. And you don't need to worry about trying to think it through backwards and all of that. Okay, so what we're going to do is we're going to play a little bit of taking an equation, figuring out its amplitude, period, phase shift, vertical shift, going that direction with it. And then also, what if I give you those 4 pieces of information, then can you plug them in and create the equation the way it's supposed to be? Okay? So let's try a little bit. So let's say we have f of x is 3 cosine 2x plus pi minus 1. And I want to figure out what is the amplitude, what is the period, what's the phase shift, and what's the vertical shift for that. Okay? So, first things first, does the equation that I just wrote match the form that I had up top over there? It's close. Yeah. There's one little difference there, right? Notice how this has b, and then in parentheses it's x minus c. See how this doesn't have that exactly? Okay? So we got to pull out a 2. We got to do a little factoring, actually. It's not distributing, it's actually doing the opposite. We got to pull out a 2. So 3 cosine. If I pull out that 2, then I'm going to have x plus what then? How do you take a 2 out of pi? Pi divided by 2, right? It's pi. Now it looks the same. Now I can just take all the little numbers off of it. Okay, so A is 3, B is 2, C is pi over 2, D is negative 1. They're all right there, ready to go. Okay? So what's the amplitude of this wave? 3. Yep. So when I graph this thing, the wave should be 3 and then go down 3 and then come up 3 and then go down 3. Period. How far until it starts to repeat itself? 2 pi divided by b. So it should be just pi, right? Because 2 pi divided by b, but b is 2, right? So 2 pi divided by 2, the period is only pi this time. So every pi, it's going to repeat itself this time. What's the phase shift? How far left or right has it been moved? Left pi over 2. Good. Remember, that's the opposite as well, right? If it's positive, it's actually going to the left. If it's negative, it's actually going to the right. So that's been moved to the left, pi over 2. And what about the vertical shift? How far up or down? Down 1. Yep. Yeah, good. Okay. So, my classes, I make them sketch graphs of these by hand. I'm not going to make you do that. What I am going to have you do, though, is take out your calculator and let's take a look at this thing and see if it matches what we just said. Those 4 things we just found. Is that actually happening? So, one thing you got to be careful of, whenever you're graphing anything involving trigonometry on your calculator, the mode of the calculator has to be in radians. Okay? Unless I'm telling you it's in degrees, we have to assume it's always going to be in radians with these. So to do that, if you go to mode, see how mine's in degrees, so I got to go down, make sure I switch it to radian. And now I can go and start taking a look at it. So, y equals, let's clear out the other stuff there. All right, so I had it to start with here. So it's 3 2x plus pi. Everybody know where to go find pi? It's second and then the caret button. And then parenthesis minus 1. So it should look like that. Now, we're going to have to work a little bit with the window here, okay? Just to make sure we can see it. Max. Okay? Think about how big the period is. The period is only pi, right? How big is pi? A little bigger than 3, right? So my window doesn't have to be that big. If I have a couple of periods in there would be nice. So maybe like a -5 to 5 or something would be good. That should give us plenty to look at. You can keep the scale at 1, that's fine. The y min and max. The amplitude and the vertical shift kind of set this up. It goes up 3 and down 3. So maybe -3 to 3. But the vertical shift moved everything down 1. So what are some numbers where we're definitely going to still see everything? -5 to 5 again, maybe? That should be good. That'll definitely keep everything within the window. So when you're graphing these, you kind of have to think about that a little bit. Kind of try and visualize where it's going to be in your head. And then, okay, I got to kind of shift those up a little bit. So, graph. Here's what we got. Okay. And so let's just double check some things, okay? We said that the amplitude was supposed to be 3. Okay. Now some of you guys might look at this and say, doesn't look like 3. That only goes up to 2, Mr. Herrick. But keep in mind, the whole thing shifted down 1, right? Because of that vertical shift. So technically it's not going up to 3 anymore. It's only going to go up to 2. Now how far down should it go, though, then? Down to 4, right? Because it normally would go down to -3. But again, we shifted the whole thing down 1, so it's really going all the way down to -4 now. So take a look at the graph. Does it make it down to -4? Yeah. Yep, that worked too. So we verified things. That's definitely happening. Period was pi. So remember we said period, if you go from like peak to peak, or trough to trough, whatever you want to call it, should be approximately 3, a little more than 3. So if I'm going to start down here because I think that's easier, we can just count along here. So is this next minimum about 3? A little more than 3? Looks pretty good to me. 1, 2, 3. Yeah, just a little further. Yep. So the period is pi. And then the other thing we were looking at was the shift, left and right. Okay. This is a cosine. Normally, a cosine has a hill right here, right? But now it's been moved over. I guess, well, which way did it go? Left or right? Can't remember. Went to the left? Okay. So it went to the left this way. It's supposed to be pi over 2, right? So normally that hill would be right in the middle, but now it should be pi, or half of a pi. So maybe about 1.5, a little more than 1.5. So look at the hill right here. Does that appear to be a little bit more than 1.5 shifted over? Mm-hmm. Yep, looks that way. Yep. So we're able to take a look at that and kind of verify. Yep, we got there. So, okay. So what we're doing is we're taking just this regular cosine that you guys came up with yesterday, and we're moving it around. Okay. And 4 pieces of information down here can describe exactly how that got shifted and moved around and all of that. Okay. So let's try the other way. Start with this information. I'll give you these 4 numbers, and then see if you can use that to make the equation. Okay? So let's say we've got, let's say the amplitude is 2. Say I'd like my period to be 6 pi. I want my phase shift to be pi. And I want my vertical shift to be, and this would be to the right then. And let's say our vertical shift is 3 going up. And just because we have it, let's go ahead and use sine with that. All right. So I'm going to help you with getting the A, B, C, D, and then I want you to put it all together. So, and most of these you can probably just tell me. What is A? A is 2. Here's the tough one. What's B? Well, 2 pi divided by B is supposed to equal this, right? So maybe come on, work that out for a second. 2 pi B has to equal 6 pi. It's 1/3. Yep. Okay. 2 times 3 is 6, right? So 2 divided by 1/3 is also 6. Does that make sense? Multiplying by 3, dividing by 1/3 is the same thing. So it's 1/3. Okay. So B is 1/3. What's C? Just positive pi. Yeah, just D. 3. Numbers. Make it a sign this time. See if you can get it. And I'll freeze it and write it down here and then show you in just a second. And if you haven't, go ahead and distribute the 1/3 as well. And then I'll take it to its like simplified form there. All right, has everybody got something? Want to see what I have? If I can find my little remote. Okay, here it is. 2 sine 1/3 x minus pi over 3 plus 3. How'd we do? This? This? This is the simplified form here, yeah. So this is kind of initial plugging everything in, and this is simplified. So how like that? Yeah, you got to distribute the 1/3 to x, which is 1/3 x. And then if you multiply 1/3 times pi, think of it just as pi over 1, if that's helpful. 1/3 times pi over 1, 1 times pi is pi, 3 times 1 is 3, so it's pi over 3. Be honest, did anybody put a plus here instead of a minus? No. Thank you for being honest. Yep. Okay, so just be careful. When you plug in the original, whoops, that's not moving yet. The original that we talked about that we're going to use, it's a minus c, right? So whatever we came up with c, it's got to be the opposite then of what we had. So just be careful of that too. But distributing and then remembering the little minus is, once you know those 4 numbers correctly, A, B, C, D, those are really the only 2 traps you're going to fall into. What? Y is what positive? It was positive because I made it that way. But notice how the phase shift was actually left. It was a plus sign, but it still said left for the phase shift. This one was to the right, so it's the opposite sign. It's going to go negative instead. Yeah, Brock? I haven't decided yet. Probably, but I'll let you know. Sketching this stuff. If I have 4 at the same time, that gets pretty difficult to sketch. However, if it's just like one thing happening, we should be able to still pull that off. Okay? So we're going to try that, just doing some quick sketches. And I think it's going to be important for you guys to know, like, what is enough. Because you can get kind of the amount of detail you want to put on these things, and I don't need it to be crazy detailed. But there is a minimum amount of information that I need on your graph so that I know that you know exactly what happened. Okay? So we're going to kind of step through this a little bit. So how do you sketch some of these trig functions the right way? What do to remind yourself, you did this yesterday. Just quickly jot down what a regular, nothing transformed yet, cosine looks like, and what a regular sine looks like. Those to help us do these other transformations and draw little sketches of them. So a cosine, I remember cosine hill in the middle. So it has that kind of a look to it. This is 2 pi out here, and this is negative 2 pi there. And it goes up to 1, comes down to negative 1. So it has that kind of a look to it. So this is cosine x, I guess y equals cosine x. Sine was also wave shape to it. Starting at a hill, it started by going through the origin. So this one would come up and then do this kind of a thing. Other way and do that. Okay, and again, this was 2 pi right here, and this was negative 2 pi. Just like cosine, it goes up to 1, comes down to negative 1. So there's your y equals sine x. So we're going to be transforming. Okay, so taking one of the 2 of them and changing the amplitude. Say that's it, okay? So let's draw a sketch of what 3 sine x should look like then. So if I've changed my amplitude from 1 to 3, what's the only thing that's going to change about that sine graph that I have up there? It's going to go up and down a little further than it does right now, right? Is the shape of it going to change at all? No. So really, I can just copy this and change some of the numbers on the scale so that it matches the right way, right? It's kind of it seems like a cheater way to do it, but it's exactly right. So I'm just going to take my sine graph, just redraw it. So it's going to go up, down, through the middle, up, down, back up. This is still negative 2 pi. This is still 2 pi. Except now, because the amplitude changed, 3, negative 3. Do you see if I don't label my axes, how I am not actually able to demonstrate that I know what changed? Right? It makes all the difference in the world. So just do that, though, and it's fine. Okay? It's got the right shape of a sine wave. It's going through the origin like it's supposed to. It's still going negative 2 pi. That's fine. The only thing that changed was how low it goes. So, all right, I'm going to make the top 3 and the bottom negative 3. Done. That's all you got to do. What if I change the period, though? So let's say I got, and we'll do a cosine this time. So how about cosine 4x? So notice how there's no like plus or minus anything in the middle there. So there's no phase shift to worry about, no distributing or any of that sort of thing we got to worry about. We've just got cosine 4x. Okay. So if it is 4x, what's the b? 4. Okay. So b is 4. What's the period? Or but maybe a better question, how would I find the period? What? 2 pi over 4. Which is? Be a half pi over 2, however you want to say it. Yep. Okay, so I need to make a cosine graph where the period, instead of 2 pi, is now pi over 2. See how I can do a little cheater method on this one too? Copy that cosine graph, change the scale so it works for you. So cosine looks like this. Amplitude still 1, right? Nothing in front, so that's at 1. That's at negative 1. What am I going to put here and here, though? Right? Period's pi over 2, right? So from to maximum, that's one full cycle, right? That's one full period. 2. If I go backwards, there's one full period from there to there, negative pi over 2. Make sense? Okay, just changing my scales to do that. Or vertical shift going on, then you can't just steal the graph and change the scale, because you're not just stretching or shrinking, you're moving it up and down, left and right. And so you have to kind of think about it a little bit more and think about how it would shift. Still do it, though. So let's say I've got y equals, we'll go back to the sine. X minus pi over 4. Let's sketch a quick graph of that. So how exactly did it move? Down just to remind myself of that. Move to the right, pi 4. So take this graph up here and scoot it to the right, pi over 4. Okay? So let's see if we can do that here. Okay, so normally sine is coming up through the origin. to the right pi over 4, where's it going to be coming up through the x-axis then? At pi over 4 now, okay? So I'm going to start there, and then I'll just finish off the rest of it here. And so then this one's going to come down, kind of do one of those. Didn't really make my scale very good here, but that's pi over 4. Still coming up 1, still down to -1, but now it's scooting up through pi over 4. And we can figure out, I always like to put where it starts and where it ends here as well. So normally, where does it start and finish? Both of them are 2 pi, -2 pi, +2 pi. I've moved everything to the right, pi 4. Where does it start and finish then? How do you add? Let's start with where it finishes. Normally it's 2 pi. I got to add pi over 4 to 2 pi, right?
Yeah.
How do I do that? 9 pi over 4. Think fractions, right? If it's 2 pi, that's 8 pi over 4, right? 8 pi over 4 plus another pi over 4, 9 pi over 4. You got to get the common denominators to do it. But this would be at, 9 pi over 4. Okay? So the other one's -9 pi over 4? Right?
No.
Good. -7 pi over 4. -8 pi over 4 plus pi over 4 is -7. So this is -7 pi over 4. Okay? So with a horizontal or phase shift, if you can give me at least that much information, that's fine. Okay? So we're at the 9 pi? Okay. Normally this point over here would be 2 pi, right? But we scooted it to the right pi over 4, so I have to add pi over to 2 pi to figure out where it's stopping now. Does that make sense? Okay, so if I'm going to add these two together, one of them is a fraction. And what do I need if I'm going to add fractions together? Okay, so 2 pi is the same thing as 8 pi over 4, right? Because 8 divided by 4 is 2. So if I take 8 pi over 4 and add pi over 4 to it, I get 9 pi over 4. Okay, I did the same thing with this -2 pi. If I 2 pi add pi over 4 to it, I got to get those denominators again, so it's -8 pi over 4 plus pi over 4. 8 plus 1 is -7, so this other one should have been -7 pi over 4, like that. And if you got to go ahead and write that out, by all means do it. It's fine. Okay, I know it takes a little extra time, but if that helps you out to figure out where those are going to be, that's okay. So we've done period changes, we've done phase shifts, vertical shift. So let's see what that looks like. So how about f of x equals cosine x minus 3, something like that. Okay, so vertical shift. So taking the cosine graph, shuffle it down 3. So normally, the cosine has a little hill here at 1. If everything down 3, okay, think about where this little hill would be sitting at 1. Everything down 3. 1, 2, 3. Now that hill is all the way down here, so I should probably make this a little bit longer. So this is up at -2. So my wave is doing this. Go now. -4. Good. And then I can mark anything period. So those should be what? 2 pi, -2 pi. Looks something kind of sort of like that then. So as long as you have the max and the min labeled, -2, -4. So that's clear. So I know that you knew where those things moved to. And then again, the period where that's supposed to be. Otherwise, the shape of the thing is completely the same as what it was before. That's fine. Okay? So you're going to do anything more than just a just together. Okay? So, like I said, you're not going to be thrown with all four at the same time. But maybe they'll do a period change and an amplitude change together or something. Okay? So you change the scale on both of them. Or maybe they shift it down, but then the period changes too. So you draw it like this, but then the 2 pi and the negative 2 pi, you're going to have to change those numbers because the period's different or something like that. Okay? Nothing crazy, but, you know, little combinations that I think you guys can probably handle with those. A few of these where you're going to graph them on your calculator and just sketch what you see, and that's fine. Okay? So, any questions before I set you loose? Okay. Then we will be done.